Imagine you're sitting here watching this video, but somewhere, in another reality, there is also a you watching this exact same video, except one tiny decision in the past sent that person's life in a completely different direction. The idea of parallel worlds sounds like pure sci-fi, but behind it are serious hypotheses from cosmology, quantum mechanics, and modern mathematics. In this video, we'll walk through 7 of the biggest theories, from gigantic bubble universes to hidden dimensions where another version of you might be living the life you once missed. Number 7. Bubble universes when the Big Bang didn't happen just once. In the classic picture, the Big Bang is a single moment that starts a single universe, ours. But in inflationary cosmology, especially the eternal inflation scenario, that picture gets much more complicated. Instead of one explosion and smooth expansion, the inflation-driving energy field may decay unevenly. Some regions freeze out, early inflation ends there, and they become universes like ours. Other regions keep inflating forever, allowing countless new bubble universes to form. Picture a pot of boiling water. The surface is expanding. Bubbles appear, rise, and pop. Each bubble is a child universe, with its own Big Bang, its own history, and potentially its own physical constants. Slightly different, electron mass, slightly stronger, or weaker gravity, maybe even a different number of spatial dimensions. In many versions of string theory plus chaotic inflation, this cosmic landscape may contain up to 10 to the power of 500 different ways to set the constants in that view. Our universe is just one bubble rising in an endlessly swelling sea. The unsettling part is this. We can't directly see through the walls between bubbles. If another bubble collided with ours in the distant past, it might leave faint traces in the cosmic microwave background. Unusual circles, slight asymmetries in the temperature map of ancient radiation. Some research groups have searched WMAP and Planck data for such signatures. A few anomalies have been reported, but the evidence is not strong enough to conclude another universe crashed into ours. Until better data arrives, bubble universes remain overwhelming in scale and sealed enough that they're hard to kill off cleanly. Number 6. The quantum multiverse. Every choice splits reality. In quantum mechanics, every particle is described by a wave function, a mathematical object encoding all possible states of a system. When unobserved, an electron can be here and there at once, but when measured, you see one result. The painful question is what happens to all the other possibilities. The ManyWorlds interpretation, proposed by Hugh Everett, gives a radical answer. There is no wave function collapse reality branches, and each possible outcome lives in its own branch universe. That means when you flip a perfect quantum coin, the universe does not choose heads or tails. It splits in one branch, heads in another, tails. When you face a life fork study abroad, or stay, confess or stay silent, every mathematically allowed choice has a branch. ManyWorlds says all of them happen. There are versions of you who took the path you missed, who lived the life you sometimes wonder about at night. What if I had chosen differently? In that huge state space, you are no longer a single individual, but a probability distribution spread across countless branches. From a physics standpoint, ManyWorlds is attractive because it keeps Schrödinger's equation intact. No extra collapse, magic required. Everything is unitary, deterministic, and reversible at the global level. The catch is that we classical observers trapped in one branch never see branches interfere again once they have decohered too far apart in Hilbert space. The hard part is intuition. It asks you to accept that near infinite copies of yourself exist, and every tiny action becomes a real split of reality. If that's true, where is the original you? Or was that question meaningless from the start? Number 5. Brane Theory. When our universe is just a sheet floating in higher dimensions. In extended versions of string theory, especially M-theory, space does not stop at the 3 dimensions. We know it may have 10 or 11 with extra dimensions curled up at tiny scales or populated by structures like strings and branes. Our universe, with all galaxies, stars, and planets, might be only a 3-dimensional membrane. A 3-brane drifting in a higher dimensional background called the bulk. This gives a very different picture of parallel worlds, not totally disconnected universes, but different branes layered in the bulk, potentially separated by an extremely small distance along a direction our senses cannot access. On each brane, fields and particles may be trapped like vibrations on a drumskin. So beings on one brane never directly see neighboring branes, but some forces, especially gravity, may leak through the bulk and thread between branes. Some brane world cosmology scenarios even suggest the Big Bang could be the aftermath of a brane collision. Two parallel universes slam together, kinetic energy converts into hot radiation, and a new universe ignites. If that picture is right, the gravity we measure, far weaker than other fundamental forces, might be weak, because part of it leaks into nearby branes. Much of gravity's flux would spread through the bulk, not just our universe. When physicists search for tiny deviations from the inverse square law at short distances, or odd gravitational signals at very low accelerations. One motivation is this. Maybe those stubborn numbers hide faint fingerprints of neighboring brane universes right next door.